who will tell us about an exploration of BIM and lean interaction in optimizing demolition projects, as you can all see.
Hello, everybody. I'm Ahmed Mouraghi, a master's graduate from Cairo University. And the co-authors in this paper are Hans Voordijk from University of Twente and Mohammed Marzouk from Cairo University. They are both my supervisors in the master's thesis. So we will start with the introduction and then exposure to Dutch industry practices in new construction processes, why we choose pool planning, and why BIM. And then we'll talk about the BIM lean interaction matrix. And then finally, we'll end up with the conclusion. So first of all, I will start with this quote. All buildings are predictions, and all predictions are wrong. This means that the current building assets normally fail to adapt to the changing functional needs of users. The result is normally buildings are partially or fully demolished or renovated. This is one of the examples in Hogekamp building in University of Twente. Even the current practice within a BIM environment, they treat demolition process as something out of the supply chain or out of the cycle loop. A large portion of building materials are either sent to landfills or incinerated, and the result is a lot of waste, construction and demolition waste. Next, we will talk about initiatives in the Dutch construction industry. We will start with the Grootvrumshoop. It's a system builder. Of course, in system building, the reuse of materials is easier than conventional buildings. However, the problem faced is the new customers' reluctancy to use the salvage elements in their new buildings. However, we can quickly find that they follow a circular loop in their supply chain, whether it's a long-term structure or short-term. Whenever it's demolished, they take out the elements that can be reused, put them back in their storage, and then when there is a new demand, they reuse these elements again. Another example is from the conventional buildings. The company is called Resource Limburg. It's in Heerlen, in Netherlands. It's a social enterprise that aims at optimizing the use of demolition waste and engaging workers with disability. Let's say in our words that Resource Limburg acts as a consultant for the owner. They take the building and then they try to find the elements with high reuse potential. In this example, we have the Mondrian building. They took out the elements like the air terminals, the doors, and then they published them on a web shop, and they put price tags on them. So we reached the question of why we thought about pool planning. Although literature was very scarce concerning linking pool planning or lean principles in deconstruction projects, it was only related to construction waste, but demolition was rarely mentioned. However, Schultman and Renz, they implicitly hinted about pool planning by saying that the nearest manufacturing typology that best suits deconstruction processes is make-to-order production. And make-to-order, I usually like to remember the Big Mac sandwich and how once you get the order, everything is prepared together. So make-to-order means that there should be a pull signal from the end customer, and then everything starts. Another term is called selective dismantling. It was also proposed by Schultman and Renz in 2001. It's retrieving elements with high reuse potential, and the rest of the building will be demolished in the normal way. So by combining the two concepts, we have reached an updated concept of selective dismantling, which is retrieving elements with high reuse potential, but based on the end customer needs. The second step is why we thought about BIM, or Building Information Modeling. According to Hubner et al., the deconstruction process is complex, and so because there are many undocumented conditions, because most of the buildings did not witness the BIM era, so there is no digital documentation of them. So the decision for selecting the elements with high reuse potential takes a lot of time, so we need a lot of planning time. Accordingly, we need a repository or a hub that can integrate the data together, and hence Hubner has also mentioned that the use of BIM-based capabilities can leverage the deconstruction process. So when thinking about the two principles, putting them together, the thing that came to our mind is to use the Professor Raphael Sachs, the BIM Lean Interaction Matrix. It was also extended to be used in operation and maintenance, and the best thing about it is that it fits our research because it's an exploratory research. So we measure the 2D perspective between BIM principles, lean principles, and BIM functionalities. This is the shape of the matrix. Here we have the lean principles, and on the other, vertically, there is the BIM functionalities, and then there are the interactions together. With the lean principles, we have mentioned 17 main principles. The classification of them was according to the strategic management related and operational planning related. As for the BIM functionalities, we have mentioned 17 functionalities that were mentioned in literature or in industry, in a demolition context. Among them, there is the reuse of model data, connecting to external libraries for retrieving data, creating dynamic scenarios to detect clashes. And this point in particular, there is, if you only have a point cloud data from a laser scanner, you can directly use it to have a dynamic clash detection of a BIM object. So how, for example, you have a BIM object of a pipe, how you can take it out of the building, you can just use the point cloud data even without modeling the whole building. And the last thing is integration and update of BIM database from online applications. So here is the matrix table. You can witness the BIM functionalities and the lean principles. And here are the interactions. Afterwards, for each number that were mentioned in the cell, there is an explanation of this interaction. And the evidence, there were 4 types of evidence. Either they were mentioned in a construction context and there is no proof of them being used in deconstruction. Second is that they are used in deconstruction but from research. And third is they are used in actual demolition projects. And the fourth is some like hypothesis that might be useful in the future in the demolition projects. An example of the interaction analysis is between BIM functionality, which is the integrity of information provided in the model, and against the lean principle, careful selection of technology that reaps high value. Actually, this between two brackets means that this was a negative interaction, although BIM modeling is way better in model integration compared to 2D CAD drawings. However, there is still some data loss, and there is some BIM authoring tools cannot explicitly detect the relationships between different BIM objects. An example of which is this pipe or this duct. This duct is around 30 meters tall, and if you model it on Revit, it won't say anything because there is nothing wrong. But in reality, there is not a 30-meter duct that can be used once. It must be put or assembled from pieces. Another thing is one of the BIM authoring tools, Revit. It allows you to have electrical conduit in the panels, in the glass of the panel, which is unrealistic. And also another example would be you cannot detect, for example, if this is the wall, how you can take out or how you calculate the elements that, the MAP elements that pass through the wall or the air terminals and so on. There is no relationship between these things, although they are already embedded in the wall. Another example is synchronizing BIM models with online applications against planning the decision-making structure early in the process. Between them, there was an interaction, and what we say here is that using a web shop that sells elements, you can, whenever an element is sold, the BIM model can be directly updated, and hence you can update the execution process of deconstruction directly. So the Resource Limburg company had asked us for improvement of their process, and we suggested the connectivity of the BIM model that they already have of the building with the web shop in order to increase or facilitate the execution process. From the interaction summary, we have reached around 154 interactions. 90% of them were positive, which is a good indicator. These were the principles and functionalities with the most interactions, and those were the least interactions. And in particular for automatic generation of reports, it was also mentioned in the previous, the original paper, that even in deconstruction, when you have easy of generation of reports, you get confused with a lot of numbers. Finally, we have studied the BIM lean interaction in a 2D perspective because this was the first step, or the exploratory research. We suggest that since this process is way complex, we suggest using system dynamics like causal loop diagrams and so on to better identify the interdependencies between BIM functionalities and lean principles. However, there was a mere evidence that there are synergies between lean principles and BIM functionalities. And we built up on that, because that was the first part of the research. We built up on that on creating a generic framework that implements it on the strategic and operational level. And when studying the BIM capabilities, and we found out that there was some drawbacks in detecting the relationships, we have developed a plugin, a BIM plugin that detects these relationships and show them on as a network, so you can detect several things using the network analysis. This was the end. Thank you so much.
Excellent.